Hi friends, today we will see about the hunting in a synchronous motor. Okay, so synchronous motor will rotate. Okay, so this is the stator and this is the rotor. So the rotor, actually salient pole rotor, I have taken like this, the construction for the simplicity. Okay, so now both are rotating in this direction. That means stator field is rotating in this direction and rotor is also rotating in this direction. So both are rotating at synchronous speed and at no load. Okay, and at no load, so these two will attract each other, they will be locked. Okay, so these two both will be locked and rotating like this. Okay, both will be rotating like this, understand? So at no load, so delta is equal to 0. So delta is the angle, so load angle. So actually these two are locked each other, they both align in the same line. Okay, so if both align in the same line, then delta is equal to 0 at no load. Okay, now, so what is delta? This is load angle. Okay, delta is called load angle. Okay, now if you increase the load, okay, suppose if you put some load, so these two will not align each other. Okay, so it will be lagging some angle. Okay, so by an angle delta, that is load angle. Okay, so for the, let us take a load of P1. So for that load P1, so the load angle will be delta 1. Okay, that means, so if N and S are here and the rotor shift its position like this. Okay, so this is the rotor axis, so the angle will be delta 1 and the delta 1 will be maintained. Okay, and both will be rotating at synchronous speed again, understand? So that is for the load P1. Okay, that means if you at no load both will be aligned like this. Okay, so both will be aligned like this, and at if you increase the load gradually, okay, if you increase the load gradually, the rotor moves like this slowly. Okay, the rotor moves like this slowly and align in this position and continues to rotate like that. Okay, by maintaining the load angle delta 1. Okay, so that is the case when you increase the load gradually. Okay, this is very important, gradually. So when you increase the load gradually, so it will move slowly and it will be like this. Okay, and both the stator field and rotor will maintain delta 1 and rotate at synchronous speed. Okay, that is the case. Now what is hunting? Okay, that means if you increase the load gradually, this will happen. If you put the load suddenly, okay, so then hunting will occurs. Okay, if you put the load suddenly, then hunting will occurs. Okay, so by the load P1, okay, you are putting the load P1, so this is delta 1. Okay, so if you put the load suddenly, okay, so what will happen initially? So the speed decreases. Okay, so the speed decreases, and it will come to like this, it will come to the position of delta 1 angle. Okay, this position. Okay, so but it will not stay there. Okay, so it will come back again to another position like this. Okay, so this will be another delta 1. Okay, actually it has to stop here, but it will not stop because you put the load suddenly, so it will come to this position again. Okay, and from this position it will go like this to again to this position. Okay, so let us assume this is no load position 0 and okay, and this is delta 1, this is another delta 1, so let it be delta 2. Okay, so again comes to this position and again comes to this position. Actually it has to stay, it has to stable at this position delta 1. Okay, but it will not stable that at this position because you put the load suddenly, so it will oscillate like this, it will oscillate like this. The condition is there is no damping. Okay, if there is no damping, okay, so the rotor will oscillate like this from 0 to delta 2. Okay, so that means above this is the equilibrium position, it has to stay here, so it will come like this and it will go like this. So that is the called hunting. Okay, that means hunting is defined as it is a phenomenon involving the oscillations of the rotor around its new equilibrium position. Okay, at no load this is the equilibrium position, at a load P1 this is the new equilibrium position. Okay, this is the new equilibrium position, it will oscillate around this new equilibrium position. Okay, so the phenomenon involving the oscillations of the rotor about its new equilibrium position is called hunting. Okay, now we will see how this hunting will occur. Okay, um, actually at equilibrium condition there will be two cases. Okay, we know power developed is equal to power input to the machine is equal to EV by xs into sine delta. Understand? So if you put a load P1, so it will become delta 1 at equilibrium position, this condition should be satisfied. Okay, so let this will be Pm. Okay, so P1 is equal to Pm sine delta 1, this should be satisfied. Understand? So and one more condition, Nr should be equal to Ns. Okay, so if these two conditions will be satisfied at equilibrium position. Okay, so now we will see. So at this position it is rotating on no load. Now you kept the load suddenly. Okay, so it will come to position delta 1. Okay, so at delta 1 the load will be equal to the power input. Okay, but at when it comes first to the position of delta 1, okay, so power will be equal, but this condition will not be equal at that position. So Nr will be less than Ns. Okay, Nr will be less than Ns. So because of that uh, it will try to come to position delta 2. So that means if it is coming like this, so delta will be increases. So when delta increases, power input increases. Okay, power input increases than the load. Power input increases than the load. Power input means Pm sine delta. Okay, so Pm sine delta is greater than P1. Okay, so because load is increasing, because angle is increasing. Okay, so when angle is increasing, power input is increasing, so power input is greater than the load torque. Okay, so it is accelerating. So it is accelerating. That means from this position to this position it will accelerate. That means, so here actually Nr less than Ns, so it is accelerating from this position to this position because Pm sine delta is greater than P1. So by the time it comes to the position of delta 2, so here Nr is equal to Ns. Okay, Nr is equal to Ns at this position, but at this position Pm sine delta is greater than P1. Understand? At this position Pm sine delta is greater than P1 because delta is more. Okay, actually here Pm sine delta is equal to P1. If it is coming like this, delta is increasing, so here Pm sine delta is greater than P1. P1 is the load. Okay, P1 is the load. So here equilibrium is not at established. So here again power input is more. So power input is more, so that it will try to accelerate more than the synchronous speed, because at this position Nr is equal to Ns already. So it will try to accelerate more than synchronous speed. So it will go like this again. Understand? It will go like this. So at this position, okay, at this position now Nr is greater than Ns. It is coming like this. Okay, now Nr is greater than Ns at this position and the power will be equal. So Pm sine delta is equal to P1 here. Understand? So Pm sine delta is equal to P1 here, but equilibrium is not at established because Nr is greater than Ns. Understand? So Nr is greater than Ns, it has to decrease. So it will move like this. Okay, it will move like this. So that means it has to decrease the power input. That's why it has to decrease the power input so that Nr will be decreases. Understand? So Pm sine delta, okay, should be decreased. That means delta should be decreased. So it will move like this. So then delta will be decreases. So at this position, at 0 position. Okay, so again nr is equal to ns. Okay, so the speed will be decreases, but at this position what will happen? Pm sin delta is 0, because delta is 0 here. So Pm sin delta is 0, so low torque increases, low torque dominates. Obviously there is no input to the machine, so low torque is there. So again coming to the starting position, understand? So it will come like this again, and again it will go like this, it will come like this, it will go like this. I hope you understand, right? Okay, so these two are the conditions should be satisfied for the equilibrium. Okay, so uh, at any position one condition will be satisfied, another will be not satisfied. Because of that it will try to oscillate, it will try to come to the equilibrium position, understand? So if you draw the graph, okay, so this is the time versus delta. So this is 2 delta and this is delta, let it be delta 1, 2 delta 1. Okay, so now initially it is 0. Okay, if you suddenly put the load, it will go to 2 delta 1 and it will come to like this, it will go like this, 2 delta 1. And the condition is provided there is no damping and there is no losses, so it will go like this. So if there is a damping, okay, if there is a damping, what will happen? So this is delta 1, this is 2 delta 1. Okay, if there is a damping, it will like this. That means it will come to the equilibrium position finally. Okay, so I will compare this analogy with some known analogy. Okay, so let us take a simple balance, let us take a simple balance. So this is a simple balance. Okay, sorry, so here there is a 1 kg is there. Okay, so here, so it is like this. Okay, so it is like this. Okay, now it is an empty. Okay, so that means delta is equal to 0 position, this one. Okay, so if you keep the load gradually, okay, if you keep the load gradually, what will happen? So both will come to this position, understand? So it will come like this down and it will go like this slowly. So if you keep the load gradually here, so this is delta 1, equilibrium position now. Okay, so now instead of that, so you are putting the load here suddenly. Okay, you are putting the load here suddenly, so what will happen? It will go down here. Okay, it will go down and it will be here and it will be like this, understand? And again it will come down and it will go back again, this position. So it will oscillate, it will take so much of long time to come to the equilibrium position. Okay, so generally in all physical systems, the what is that called, generally in all physical system, okay, why this came like this? So because of, okay, so that will happen. Okay, damping. Okay, sorry. So because of damping, it stabilizes. So generally in all physical system, damping is inherent. Okay, so that's why, so the simple balance will come to the stable position finally. Okay, if you keep the load here gradually, so it will come to this position, okay, slowly. But if you put the load suddenly, so it will oscillate. Okay, it will oscillate about its final equilibrium. This is the final equilibrium position, this is the initial equilibrium position, this is at delta is equal to 0, this is at delta 1. Okay, that means some load. Okay, understood? I hope you understand. Okay, thank you.